Hello, today I will be going through some basic derivatives and rules for combining them. So, just as an intro, the notation for this will be either derivative of f of x is f apostrophe x, or d divided by dx of the function. The derivative is the limit of h going to 0 of f of x plus h minus f of x all divided by h. This just calculates the tangent line of the function, the slope of the tangent line of the function at a given x. So here's an example. Let's say your function is just a constant, so d divided by dx of c. That just equals 0, and as you can see here, this is y. F of h of x of this function is just c minus c equals 0 divided by h. And because h is approaching 0 and not equaling 0, this just equals 0. No division by 0 in this case. For f of x equals x, as you see here, it becomes x plus h minus x divided by h. The x's cancel out, giving you h divided by h. This equals 1. You can cancel out the h's because there's no division by 0 here, and it equals 1. And here's another basic example. Let's do the derivative for x squared. So we have the square of x plus h minus the square of x all divided by h. I know a lot of people would just try to expand x plus h, and then you would have to cancel out the x squares and all of that. But what I like to do is I like to consider this a difference of two squares. So you have x minus x plus h, so that's h. And then you have x plus h, which is, 2x plus h. You can cancel out your h's, and that will give you 2x plus h. H goes to 0, which leaves you with just 2x. So what this means is, on a parabola with the function equaling x squared, the slope of the tangent line at x, the slope of the tangent line will be 2x. So at 1, the slope of the tangent line will be 2. At 2, it will be 4. At 2.5, it will be 5, and so on. And at 0, it will be 0. So that means you have a horizontal tangent at x equals 0. Here are a few more. This is trigonometric derivatives. Two identities that are used for this are shown on the side, highlighted in green. Limit of x going to 0 of sine over x divided by x equals 1, and limit x going to 0 of cosine of x minus 1 all divided by x equals 0. And here's our first one. I know it's a little bit much, but we can go through this. We're taking the derivative of sine of x, which means that we go to sine of x plus h minus sine of x all divided by h. If you know the sum of angles in a sine function, this is what it gives you. And then you minus it by sine of x. You can factor this, which is shown as this. You notice here that we have sine of h divided by h. Because h is going to 0, we can apply this rule on it. That means this value becomes 1. And as you see here, the second rule will apply because h is still going to 0, and you can say that equals 0. That results with cosine of h times 1 plus sine of h times 0, which just equals cosine of x plus 0 equal cosine of x. And here's our second example. This one is for cosine of x. You notice that we're doing the same thing here. We're finding the sum of angles for cosine of x. That equals a certain number. We factor it out, and you see our two identities. We bring those identities to each of these values. That equals 1, that equals 0, and that results in negative sine of x. Okay. Here are some basic rules to combine derivatives. This will be going over 2 slides, so don't assume that the first 2 I'm showing you is everything you have. So here's a basic one. Adding up 2 functions and finding the derivative of them just is the same thing as finding the derivative of the 2 functions and adding them together. So that was a simple one. Here's a much more complicated one. The derivative of a function within a function equals, I made a mistake here. This g of x should just be a regular g of x. So this thing is not here. It's just the derivative of f of g of x times the derivative of g of x. I will prove all of these later in another video, but chain rule, it's a complicated one. I'll eventually prove this one, but it's very essential for certain functions. Here are some more rules to combine derivatives. This is called the power rule. You see we have x to the power of a, and we want to take the derivative of it. That gives us x to the a times x, all to the power, not all to the power, a times x, and x is to the power of a minus 1. The ones that I'm showing on this slide will also be proven in another video. Here's another one. The derivative of the product of 2 functions equals the derivative of the first function times the second function plus the derivative of the second function times the first function. And you see here I have underlined each of them. I also did that on the previous one. I have underlined each of the functions with these colors. So if you can't understand this, you can just go back to this and figure out which one is which. I did that because the apostrophes will get complicated, and as in the previous one, that one I got it wrong, but that one I didn't put the underline. So be careful. This is not the derivative of g of x, it should just be g of x, and I'll show this in an example. Here's our final one. Here's our final rule for the day. If you want to take the quotient of 2 functions, it equals this monstrosity. Here's how I like to put it. Take this function. If you can remember this, you can easily find this. Take this, turn this into a minus sign, and divide by the denominator squared. So that equals derivative of f of x times g of x minus derivative of g of x times f of x, all divided by g of x squared. Here are 4 more derivatives that we can use our new rules to solve. Our first one is going to be the inverse of x, 1 over x. We can just turn this into the derivative of x to the power of negative 1, and we can apply power rule to it. So we have negative 1 times x to the power of negative 2. Remember, you have to minus 1. So that's why this number got greater. Not greater, less. Greater magnitude. And this equals, I made another error again. This should be negative x squared. So be careful when you're doing problems like this. Always check your work. Here's another fun example. We will take the derivative of the square root of x. So what we can do is do what we did before, x to the power of 1/2. Then we can apply power rule, 1/2 times x to the power of negative 1/2 because minus 1. And that simplifies to 1 over the 2 times the square root of x. Here are 2 more. These use the quotient rule and the chain rule as I showed. So let's do the first one, tangent of x. This just equals the derivative of sine of x divided by cosine of x. We can use our rule from before. So the derivative of sine of x is cosine of x, so cosine squared x, minus, note I wrote a plus, I'll explain why, minus the derivative of cosine of x, which is minus sine of x. So that's why this thing got turned into a plus. So that this whole part is plus sine squared x, all divided by cosine squared of x. If you know your trigonometric identities, you'll know that this equals 1. You can divide by cosine squared of x. You're still dividing by cosine squared of x, and then you can simplify it to its reciprocal, secant squared of x. And let's do the last one. This uses what we learned above, plus the chain rule. I am not going to go through the whole thing of solving tan of x again. If you do not want to memorize this, I do not recommend memorizing this. I recommend deriving the derivatives on your own. But in the case of an AP test, which is timed, memorize a few. Like the identities from before. The limit of sine of x divided by x going to 0, x going to 0, which equals 1. So over here, for our chain rule example, we've taken the derivative of the outside function, and the inside function is still inside. We have not taken the derivative of it, so be careful, no derivative for this, but we do take the derivative and multiply it to this. And that's why our whole answer is 2x times secant squared of x squared. Okay, I hope you enjoyed. I hope you understood just the basics of derivatives. So just to recap, here's the addition property. You can just add the derivatives together instead of adding the functions and then finding the derivative. Chain rule, this thing is a monstrosity, but I will prove it one day. We have our product rule. First we have our power rule. This is also an essential that you should learn. I'll show you how to derive each of these on their own in another video. We have our product rule, and then we have our quotient rule. Alright, I hope you enjoyed. I hope you understood all of this. Please send this to someone if they need help with derivatives. And I'll link another video in the description soon, proving all of these rules. Okay, see you later.